Have you ever wondered how stars and planets, the celestial bodies that light up the night sky, come into existence? It's a captivating process that starts with a cloud of molecular gas, known as a nebula. These nebulae are primarily composed of hydrogen and helium, the most basic elements that fill our universe. In this seemingly chaotic environment, gravity plays the role of a cosmic sculptor. It pulls on every single particle in the nebula, causing the cloud to contract. As it contracts, the cloud becomes denser, and the particles within it collide more frequently and with greater energy. This increase in density and collision energy leads to a rise in temperature at the heart of the cloud. Now imagine the pressure and heat at the core of this contracting cloud becoming so intense that the hydrogen atoms start to overcome their natural repulsion for each other. They begin to collide and fuse together, creating helium. This process, known as nuclear fusion, is the power source of a star. It's the same process that powers our sun, allowing it to shine brightly and provide the energy that supports life on our planet. But the birth of a star is not a calm event. It's a violent spectacle, often accompanied by the expulsion of material in the form of solar winds. And in some cases, when a massive star exhausts its nuclear fuel, it ends its life in a dramatic supernova explosion, scattering its enriched contents across the cosmos, providing the building blocks for new stars, planets, and possibly even life. So, the birth of a star is nothing less than a cosmic spectacle, a dance of physics and chemistry under the influence of gravity. It's a process that takes millions of years, unfolding on a scale that is truly mind-boggling. But it's this process that populates our universe with the twinkling stars we see in the night sky and the planets that orbit them, including our own home, Earth. Now, while stars are taking birth, another fascinating process is simultaneously underway: the formation of planets. In the swirling cosmos, planets are born from the remnants of a star's birth. Picture a young star, newly formed, surrounded by a swirling disk of dust and gas. This is the protoplanetary disk, the cradle of planets. As the star continues its life cycle, the protoplanetary disk begins a transformation of its own. The dust and gas within this disk aren't idle. They're constantly moving, colliding, and sticking together. Over time, these tiny particles coalesce, forming larger and larger clumps. These clumps, or planetesimals, are the building blocks of planets. They range in size, some as small as a kilometer across, others as large as our moon. But the birth of a planet is not a gentle process. Picture a cosmic demolition derby. These planetesimals smash into each other, breaking apart and coming together in a chaotic dance. Amidst this chaos, some planetesimals grow large enough to dominate their local neighborhood. As these planetesimals grow, their gravity becomes stronger. They begin to attract more and more material, sweeping up the dust and gas in their path. This process, known as accretion, leads to the formation of protoplanets. Now, these protoplanets are still not the planets we're familiar with. They're hot, molten bodies, constantly bombarded by leftover material. But over millions of years, they cool down, their surfaces harden, and they take on familiar forms. But the story of planet formation doesn't end here. The gravitational interactions between these planets and the star they orbit shape their final characteristics. These interactions determine their size, their composition, and their orbit. They dictate whether a planet is a rocky world like Earth, or a gas giant like Jupiter. Thus, from the remnants of the star's birth, planets find their genesis, each unique in its size, composition, and orbit. This process of planet formation reveals the intricate beauty of the cosmos, reminding us of the interconnectedness of all celestial bodies. Understanding the formation of stars and planets is not an easy task. It involves a multidisciplinary approach, and some of the most advanced technology we have. The study of these celestial bodies is a complex dance of astrophysics, planetary science, and geology. Each field brings its unique perspective and tools to the table, painting a more comprehensive picture of our universe's birth and evolution. Astrophysics helps us understand the fundamental forces at play. It's the study of the physical properties of celestial objects and the forces that govern their behavior. From the massive stars that dwarf our sun to the tiniest particles in a nebula, astrophysics helps us grasp the scale and mechanics of the cosmos. Planetary science, on the other hand, gets a little more personal. It's the study of planets, moons, and planetary systems, both within our solar system and beyond. Planetary scientists delve into the composition, dynamics, and history of these bodies, helping us understand how they form, evolve, and interact with their parent stars. Geology plays a surprisingly pivotal role too. By studying the geological processes and history of our own planet, we can make educated guesses about the conditions on other worlds. For instance, the presence of certain minerals or the evidence of water erosion can hint at a planet's past or present habitability. The tools we use in these studies are as impressive as the celestial bodies they probe. Powerful telescopes, both ground-based and spaceborne, enable us to peer deep into the cosmos. Spacecraft allow us to take a closer look, sometimes even landing on distant worlds. And computer simulations help us model the complex processes involved in star and planet formation, allowing us to test theories and make predictions. Our own solar system serves as a cosmic laboratory, offering valuable insights into the conditions and mechanisms of star and planet formation. From the fiery birth of our sun to the icy bodies in the outer solar system, every component provides a piece of the puzzle. As we continue to explore and understand our own cosmic backyard, we move one step closer to unveiling the mysteries of the universe. One of the most exciting aspects of studying star and planet formation is the concept of habitability. This idea revolves around the Goldilocks zone, a term that might remind you of a certain fairy tale about three bears. And much like in that story, this zone is not too hot, not too cold, it's just right. But instead of porridge, we're talking about the conditions necessary for life, as we know it to exist. This habitable or Goldilocks zone is a specific area around a star where a planet, if it's the right size and has the right atmospheric conditions, could maintain liquid water on its surface. Yes, the key here is water, that precious, life-sustaining substance that makes our own planet so unique and vibrant. But the story doesn't end here. As we delve deeper into the cosmos, the study of exoplanets, planets outside our solar system, takes center stage. With the help of advanced technologies and the unyielding curiosity of astronomers, we have already discovered thousands of these exoplanets. Some of them, quite intriguingly, are located within their star's Goldilocks zone, presenting a tantalizing possibility of life beyond our planet. On these potentially habitable worlds, scientists aim to detect biosignatures or signs of life by studying these planets' atmospheres. While this is no easy task given the vast distances and numerous variables involved, each new discovery brings us one step closer to answering one of humanity's oldest questions. Are we alone in the universe? And so, the quest for understanding star and planet formation becomes much more than a scientific endeavor. It's also a journey of self-discovery, a search for our place in the vast cosmic theater. We're not just learning about distant stars and alien worlds, but also about our world, our origins, and perhaps our future. So the quest for understanding star and planet formation is also a quest for understanding our place in the universe and the potential for life beyond Earth. The formation of stars and planets is a process that shapes the universe itself. These celestial bodies are not just beautiful spectacles in our night sky, but they are the building blocks of galaxies, the massive structures that make up the universe. When we consider the formation of stars and planets, we are considering the very evolution of these galaxies. Stars, with their immense gravitational pull, draw in surrounding matter, helping to shape the distribution of material in the universe. They play a crucial role in the cosmic cycle of matter, from the dust and gas in nebulae to the elements released during supernova explosions. This constant cycle of birth, evolution, and death of stars contributes to the dynamic and ever-changing nature of the universe. Planets, on the other hand, are formed from the remnants of this cosmic cycle, the dust and gas left over from the creation of stars. They represent a different facet of the universe's evolution, one that is intimately tied to the life cycles of stars. The diverse array of planets we see today, from gas giants to rocky worlds, is a testament to the complexity of these processes. The diversity of stars and planetary systems we observe is a testament to the richness and complexity of the cosmos. Each star and each planet tells a unique story of formation and evolution, providing us with a mosaic of possibilities for what systems might exist out there in the vast expanse of the universe. In studying these celestial formations, we gain insights into the history of the universe, the origins of life, and the potential for life elsewhere. The quest to understand star and planet formation is not just about understanding our place in the cosmos, but it's also about exploring the possibility of other places, other worlds that could harbor life. It's a fascinating journey, one that continues to captivate us and promises many more exciting discoveries in the future. As we delve deeper into the mysteries of the universe, we continue to uncover the intricate dance of forces that shape the cosmos. from the birth of stars and planets to the evolution of galaxies and the distribution of matter in the universe.